Okay, in this video we're going to just kind of do a basic rundown of some of the major questions that are asked about polar coordinates. It says the graphs of the polar curves, R1 is 2 plus 2 sine theta and R2 is equal to 1 from 0 to 2n. Write an integral expression for the area inside of R2 and outside of R1. So the area that we're really talking about is here. Okay. Now, sometimes that's hard to do, but most of the time on the AP exam, that's actually given to you. They don't want the mistake to be just simply that you couldn't figure out what area they were talking about. But we do need the intersection points. So we're going to have 2 plus 2 sine theta equals 1. Subtract 2 from both sides. Like that. Now, we need to figure out when the sine is 1/2. Well, it's some multiple of pi over 6 because it's down here and here, the two negatives, it would be 7 pi over 6 and 11 pi over 6. Okay? A lot of times on the AP exam that is given to you as well, but always good to be able to actually solve for it. Okay? Now, what I really want to do then is I want to integrate, and if I integrated, let's just say the circle to begin with. 1/2, remember it's always 1/2 r squared d theta, like this, from 7 pi over 6 to 11 pi over 6. Now I'm just going to shade then what that is, and I always recommend, kind of drawing lines out. Okay, this is, I'm shading then that entire sliver, that pi piece of the circle. Well, I don't want that. I want to subtract out these pieces here. So to do that, I'll subtract 1/2 integral 7 pi over 6 to 11 pi over 6 of the other one, squared d theta. That would give me the area that's just the red shaded area. Sometimes you need to play a little bit with these areas. The big thing you need to remember is that 1/2 r squared. Okay, 1/2 integral of r squared. Do not forget that. Okay. Next. Write the expressions for dx d theta and dy d theta in terms of theta for the R1 curve. Well, remember that x is equal to r cosine theta and y is equal to r sine theta. Anytime I'm faced with a polar question, I'll usually make a note of that somewhere, unless it's area, because area, remember, area is just 1/2 the integral of r squared d theta. So this really doesn't have anything to do with the x and y, but the slope sure does. So in my case, it says, well, I want to do the R1 curve, so r is equal to 2 plus 2 sine theta cosine theta. And again, the reason is this is r cosine theta, and y is r sine theta. Okay, just substitution. So when we do the derivative, and maybe in the interest of space and time I can just talk about it instead of writing it, when we do the derivative we're going to need to do product rule. First times derivative of the second plus second times derivative of the first, and same thing for this one. Now, of course, the meaning, I put this down here, the meaning of dy dx, dx d theta, dy d theta are a little bit different. Of course, what dx d theta tells us is how the thing is moving from side to side with respect to theta. Whereas what dy d theta tells us is how it's moving up and down with respect to theta. So that leads us then to dr d theta. Well, dr d theta tells me, because r, remember, is a distance from the origin then this tells me how is it moving to or from the origin. So of course if it's positive, dr d theta is positive, you're moving away from the origin. If dr d theta is negative, you're moving towards the origin. So that we really have three things now. You know, normally like with a parametric, we just have dy dt and dx dt. How's it moving up and down? How's it moving side to side? But we really add this dr d theta, okay? And dy dx, same old meaning. This is the slope of the curve. Okay, so we have a lot of things here to think about. Now, part C says write an equation for the terms of x and y with the line tangent. Well, I actually I do want to do that. Okay, so let me do that on the next slide. So remember, x is our cosine theta, y is our sine theta. So for us, that is 2 plus 2 sine theta, 2 plus 2 sine theta, cosine theta. Okay, so when I need dy dx, I need the tangent line, dy dx, I'm going to do dy d theta over dx d theta. So we're going to have first times derivative of the second plus second times derivative of the first. Okay. On the bottom, we're going to have first times derivative of the second plus second times derivative of the first. Like that. Okay? So that's how we're going to get the slope. And of course, to get the point, because remember, for every tangent line, we need a point and a slope. So now we'll plug in 0 for theta. So of course, the sine of 0 is 0. So we're going to have 2 plus 0 times 1. And then we're going to have 0 times 2. So the whole top is just going to be 2. I'm just going to write that down here, 2 over. So here we're going to have 2 plus 0 again, multiplied by 0. And here we're going to have 1 multiplied by 2. So 1 and 2. Or 0 plus 2 is 2. Okay. So the slope is 1. Now we need the point, because for every tangent line you need a point. So now we go back up here, because we know what y and x is, and we plug 0 in. You know, so 2 plus 0 times 0. So y is 0. Let me just write the point here, kind of down below. The point is, the y is 0. And the x, well, we plug that in. 2 plus 0 times 1 is 2. So we got x minus 2 plus 0. So my tangent line looks like that. And if you can think about this, when theta is 0, right, theta is 0, we have found that the point is right here, and doesn't it look like the slope is about 1? So there's your tangent line. Okay, so there may be other things on the AP exam they ask you to do. There may be some things with some parametric. They may turn this into a parametric, because that's very easy to do. To turn this into a parametric, we already have a y equals and an x equals. So sometimes they'll have you replace the theta with t's or something like that. But if they're going to do that, remember this key. This is the key to it. Y and x, and then some substitution. They will almost always have you do an area, so remember that 1/2 integral of r squared. In terms of the meanings, just take it a piece at a time. dx, remember x always tells us how something's moving side to side. dy always tells us how something's moving up or down. dr is a little bit different. That tells us how it's moving to or from the origin. And dy dx, same old meaning for that, it's just the slope.